In this lecture we talk about variance of a Poisson random variable. So again we want to find out expectation of x square minus expectation of x, and then you square this. So this we already know that expectation of a Poisson random variable is just lambda. So for variance of this random variable x, we have to find out expectation of x square minus lambda square. So let us focus on expectation of x square. So that would be simply summation k equals to 0 to infinity k square times probability that x is equal to k. So you take lambda common outside and you do the cancellation here. This becomes k minus 1 factorial. So you copy this down. So lambda k becomes lambda k minus 1 because you have taken one lambda outside here. And now you do the substitution. You put j equals to k minus 1. So when k is 1, j is 0. So when k is 1, j is 0. And when k is infinite, j will also be infinite. So then k becomes j plus 1. So you first put j here, and then instead of k you put j plus 1. Now you can rewrite this expression as lambda times summation j equals to 0 to infinity, and then you can write down some random variable y here. So function of some random variable y times probability that y is equal to j. So this looks like expectation, and this probability is nothing but shows it is like Poisson random variable. So this will be nothing but equal to lambda times expectation of f of y. Now what is f of y? F of y we see here is j plus 1. So that means it will be y plus 1. So instead of j plus 1 you have y plus 1. So you get y is a Poisson random variable because this is the probability mass function for y, and we just copy this result down here. Instead of f of y you write y plus 1. So this will become expectation of y. Since y is a Poisson random variable, again the parameter here for y is lambda. So the parameter is lambda. So you get expectation of y plus 1. So expectation of y is lambda, then you have plus 1. So this lambda remains as such right here. Now you have the formula for the variance, which we just copy this right down here. And so you get lambda times lambda plus 1 minus lambda square, and that is equal to lambda. So notice that for the Poisson random variable, expectation of the random variable is lambda. Variance of this random variable is also lambda.